Hey everybody, Tom Cherry Holmes here with the FujiNet project, giving a quick work in progress video for what is essentially the third rewrite of the CIO driver. Why the third rewrite? Well, because the very first two were essentially test programs that were written in the old Arduino IDE, and this is the third rewrite, which is being done in the platform I/O, which will be the production form of the code. Now that most of the SIO functionality has been worked on and essentially worked through, we know that it's functioning and doing what it's supposed to be doing, we can essentially take and work through and start pushing through and start implementing the bits and pieces that we will know that we need for CIO in the form of a prototype handler that's written in C. And once we get all the functionality inside the CIO handler that we want, we can take and write the resulting handler in assembler. Now, besides the fact that the assembler version will undoubtedly be literally half the size, if not smaller, than the current C prototype, it will also be a lot more stable too, because the C runtime basically uses a lot of zero-page bits and pieces for temporary storage, which is undoubtedly messing around with bits and pieces of temporary state that BASIC is currently using. So undoubtedly there are bugs that are, that we may be tripping on or whatnot. It doesn't matter, because really the whole point is to get as much of the CIO functionality worked out as we can and say that this is the functional set that we're going to go with for the CIO handler, and then we can take and move over to assembler once it's ready. So with that, we'll actually go into our Visual Studio environment here, which we have a monitor set up for showing the SIO bus monitoring here, but we also have our Atari window open, and there's also a third window which will pop up shortly. But for now, we'll go ahead and just boot into this particular environment. This is an OSA Plus environment that I have set up specifically for developing the end device driver and testing it. If we look on the directory for this particular disk, we'll see some of the usual suspects for FNC tools, but we also see NDEV for the end device driver that we load in manually, and yeah, pretty much, and Memlo, which I use to track Memlo. My Memlo right now, before I load the device driver, is sitting at 2180. That's because I've got four disk drives attached or configured with their corresponding buffers. The Memlo is going to jump up quite a bit because, as you see, indev.com is 21 sectors long, and I've put a little space at the end so I can keep adding code without having to scoot Memlo up a bit. This is a non-relocatable driver prototype at the moment, so it's loading into a fixed location just after this. So with this in mind, we'll go ahead and load indev. And you'll see, as part of loading indev here, it will take and immediately send a status request. And if 01 is set here, this means that the FujiNet is actually active, and the handler uses this to determine that everything is okay with FujiNet here. So FujiNet's ready, boom, ready to go. There is some additional code in here to guard against accidental loading twice. I did try to take and put in some DOS-INI refactoring here, but because of the way the C runtime works, some things get clobbered on reset that don't get persisted back in, and it's not important to me that this thing persists across reboots, so I didn't complete that implementation. It's not important right now. What's important is actually getting the functional bits working. You can go ahead and go to basic now, and because this device driver is loaded, we can now do this. Recall that an end device spec has a protocol name along with a path. And you'll notice that that file name right there is longer than 8 characters. but it works nonetheless. I do have to specify a port number here at the end. Now I will say that the URL that's currently in place here is literally temporary. I'm going to be changing this to a more RFC compliant URL scheme very shortly. But if we go ahead and hit return, we will actually start to see the HTTP connection made. It will pull down and load the basic program and run it. As you can see right there, doing just fine. Voila. And there is Blackjack in all its glory. I wonder who wrote this version. Yeah, sure. Yeah, why not? I think I can press my luck there. And yay, I won. Okay, that's pretty good. That's a pretty good omen. Now, since if I do a graphic 0 here, some bits and pieces actually get wiped out of place. So some internal state kind of gets jumbled up here. So in order for me to do this next bit, I'm actually going to reboot. Again, like I said, it's a prototype. We load the end-device handler again. Again, FujiNet's now ready. Now at this particular point, we can go ahead and write a quick little program which will actually print whatever, will connect to a TCP host and then print whatever comes across on the other side. So, of course, we need a string for that, so might as well add one here. We need an open command. 12, of course, you may know, is being update, both read and write. The 2 is special because that tells it that we want to take and translate line read characters to ASCII EOLs and back. So we want to make a TCP connection to a host over here. This very host that Visual Studio Code is running on, called TMA1, on port 2000. Then, at that point, we want to immediately start looking at the proceed line and waiting on the proceed line to see if there's something that we want to pay attention to. Now recall from the previous video that I said that I had implemented interrupt-driven I/O. This is true. You can, in fact, take and put in a interrupt service routine on the proceed line, vector it into the operating system, and then react immediately when the proceed line actually changes state. It's edge detected. In BASIC, though, it's just as well and sufficient enough to simply pull the value of that transition line on PACTL, and if it changes, you can react to it. Now, because I'm sending a small blip that's, a couple hundred microseconds, the transition will happen and it will transition back appropriately. So it's sufficient enough to basically do something like this. 54018 is, of course, PACTL. And we check to make sure if it's 60, that's what it usually is. And if that's the case, then just kind of loop back and sit there. Otherwise, we grab it, we print it, we go all the way back to 120. This is kind of the bare minimum here to take and read something from a TCP socket. Done, done, and done. So, with that, we go ahead, and before we actually run this program, I'm going to bring up a third window here, which corresponds to my netcat window, in which I will actually start typing some text once we're connected. Oop. Apologies, I'm shuffling windows around here. Just a moment. Bear with me, please. Oh, come on, quit it. Let's try, see what happens. Actually, let me Control C, make sure this is nice and clean. And you'll see immediately two things happened. First of all, you saw the connection happening here, but you saw the result of the open command that got sent along with our device spec, port numbers in TCP, TMA1, port 2000, and we immediately try to connect to that host. Once it's connected, bam, there we go. We can then at this point start sending out information. And as we can see right there, you can hear that it was not doing a massive pull storm just waiting for data to come in, but it's only reacting whenever we know something is actually coming in. So, I mean, there you go. At this point, we can go ahead and just hit break, and we can close this channel, which will close the socket for us. And so there, essentially, bam, ready to go. That's working great. A few other interesting bits and pieces. One of the things that actually happens, status actually returns as part of its status output. The fourth status byte actually returns errors, extended errors. Because recall from SIO only sends a handful of error codes back, namely 138, device timeout, 139, a non-acknowledgement occurred, 140, which is a serial bus framing error, 143, serial bus overrun, etc. And 144 being basically device done, which is essentially, okay, device sent back an error. Something happened. Well, that's not very useful for when you're trying to take an established network connections. Maybe you type something in wrong, like an incorrect host name, whatever, and you need to be able to deal with that. So if I take, for example, and do something like that, what will actually happen is that it will attempt to do the open, and if the open fails, it will send back an SIO error, which will cause the CIO handler to immediately grab a status and return back in the Y register the actual error that actually occurred. And we'll see, okay, meh, that didn't work out very well, okay. It'll give it just a moment for it to actually come back through in just a second. Once it comes through, bam, bam, okay. It will try at least one more time. And you can see right there, it did what's called an error 165. And in this case, it corresponds exactly to the same DOS error as 165, which is an invalid file spec. In this case, we're missing a port number. Well, what happens if we add a port number and try again? In a few moments, we'll actually take and come back, and we should actually get an error 170. This is for a non-existent host name here. So there you go. So as I said, the bits and pieces for the CIO handler are starting to work. Things are starting to come together. And so little bit by little bit, you're going to actually start seeing interesting things start to happen. And, well, finally, I guess we'll try. I don't have interrupts really handled too much inside of here. Let's see if I'm going to take and try to test the demo gods here and just see if this works. I really am testing the demo gods here. This may not work. We'll see. Okay. Character's too long. Okay. No, yeah. It basically looks like I have an error 137, which essentially means too much data came across for that particular record. No problem. But, little bit by little bit here. Like I said, still more to do, but I kind of wanted to show you guys where things stood at this particular moment here. A lot more to do, more videos to come. So, until next time, guys, have fun.